Hi, welcome to Lesson 16a, Tangents and Normals. The goal of today's lesson is to use the rules of differentiation to find the gradients of tangents and normals to curves. So, we've been looking at all the different rules of differentiation in Chapter 15, and now we're going to start using that information to be able to sketch curves. And if we have a function that's y equals f of x, then, and we have some x value of a where the point of tangency is, so the point where a tangent line touches the curve, then the x value is a and the y value is f of a. So the point of tangency then can be written as a f of a. When we take the derivative of this, the derivative is, well, dy by dx is f prime of x. When we substitute the x value of the point of tangency in, we get f prime of a. And the gradient formula is basically y2 minus y1 over x2 minus x1, and that equals the gradient. So using this notation, this gradient notation in differentiated function equation, we would get then y minus f of a over x minus a equals f prime of a. So this is the gradient evaluated at x equals a, and this is the general y minus the specific value of y of the point of tangency divided by x minus the specific x value of the point of tangency, a. And then if we rearrange this, we just multiply both sides by x minus a, so we would get f, or y minus f of a equals f prime of a multiplied by x minus a. And then we could add f of a to both sides to get our value of y. So the general form of the equation then would be y equals f prime of a x minus a plus f of a. Okay, so that's all in general terms. We're going to take a little example to see how this all works. Now, when we find the normal, so this is all the point of tangency, the gradient of the point of tangency, the gradient of the curve at the point of tangency, because that's going to be the same as the gradient of the tangent line itself at that point. So if the gradient is f prime of a, then the gradient of the normal, that's going to be negative reciprocal of f prime of a. Okay, so that is how we find the normal to a curve at the point of tangency. So this is an example of what the scenario would look like, where we have a tangent and the point of tangency, or the point of contact here, on the curve, and then the normal is perpendicular to the tangent at that at the same point of tangency. Okay, so this is kind of the scenario and what it would look like. Okay, so we're going to take a little example here. So what we're going to do is we're going to say then that what we're going to do is we're going to find the equation of the tangent and the normal to this function y equals root of 2x plus 1 at x equals 4. Okay, so what we're going to do first is let's find out the ordered pair, or the y value of this curve at x equals 4. So y then is, or I guess f of 4 would be 2 times 4 plus 1. Take the square root of that. So that's 2 times 4 is 8, plus 1 is 9. The square root of 9 is 3. So the point of tangency is 4, 3. Okay? So this is the function y equals root of 2x plus 1. So dy by dx, we need this because we're looking for the rate of change, or the gradient function of this function. So we take the derivative of this. Well, actually, I'm just going to, sorry, just before I do that, I'm going to rewrite this into 2x, into power form, 2x plus 1 to the 1/2. Now I take the derivative, and this is incorporating the chain rule. So with the chain rule, of course, remember we multiply this 1/2 down in front. We leave what's inside, and we subtract 1 from the exponent. And then we go inside and take the derivative of the inside, which in this case is just 2. Then we'll group things together. 2 times 1/2, that's just 1. So we get, and this negative brings us down into the denominator. So we get 2x plus 1 to the 1/2. And then I'll just return it back to root form. So you get 1 over the root of 2x plus 1. Okay, so that's the gradient function, dy by dx. Now to find the actual gradient of this function at x equals 4, I'll evaluate dy by dx at x equals 4. So you get 1 over the square root of 2 times 4 plus 1. 2 times 4 plus 1 is 9, the square root of 9 is 3, so this is 1/3. Okay, and so then to get the equation of the tangent, we go y minus 3 over x minus 4 equals 1/3 by using what we saw on the previous page. And then I'll just multiply this on both sides. We get y minus 3 equals 1/3 times x minus 4. And then y equals 1/3 x minus 4/3 plus 3, well that's 9/3. So y equals 1/3 x plus 5/3. Okay, and that's in slope point form, or in a more general standard form, we could say 3y equals x plus 5. And now to get the equation of the normal, well, the point of tangency is still the same. It's still 4, 3. Same function, same derivative. But now, since the gradient to the function at the point x equals 4 is 1/3, the normal is the negative reciprocal of that, so that gives you -3. So then we can just say y minus 3 over x minus 4 equals -3. Multiply both sides, so you get y minus 3 equals -3 x minus 4. Simplify a bit, so we get -3x plus 12 plus 3. So y equals -3x plus 15. As the slope point form, or the gradient point form, we could change this into 3x plus y equals 15, if we so choose, into another form of the equation. So those are a couple quick examples, or a quick example of finding the equation of the tangent and equation of the normal to a function at a point of tangency using the first derivative. And so in the exercise part, there's a bunch of exercises, and they're kind of divided up into different sections with examples provided. So what I'd like you to do in the following order, and instead of just dictating each of these one by one, what I'm going to do is I'm going to show you the list of things that I would like you to look at in the specific order that they're listed. So I'd like you to pause the video and take a look at this, and then go to your textbook, go through the examples, take a look at the questions, the practice exercises that I'm proposing you do, and make sure that you go in order to do some exercises, examples, so that it kind of guides you through the process. Of course, making sure that you listen to the self-tutor as she explains all the key steps. Okay, so pause the video now to take a look at these. And so that would be about it. So thanks for watching, and we'll see you in class.